So today we are going to see type 6 problems. Okay. So first of all, let me note down the questions and try to solve them in a normal way and try to understand these type of questions are giving a simple equation or quadratic or cubic or any degree polynomial. So let me take the problems here. Suppose 1 upon x plus 9 plus 1 upon x minus 7. So that equal to 1 upon x plus 11 plus 1 upon x minus 9 we have. Okay. If you try to solve in normal way first and try to understand the concept, take the LCM here. So that is x plus 9 into x minus 7. And here LCM will be x plus 11 into x minus 9. Okay. After taking LCM, you can observe here the numerator parts will be x minus 7 plus x plus 9. Okay, here we are getting x plus 9 plus x plus 11 we are getting. Okay, I hope this is clear for you. And after that, if you see in the numerator, you are getting 2x plus 2. Okay, here also you are getting 2x plus 2. After that, in the numerator, we are getting the same thing. Okay, in the denominator, we are getting here x square minus, not minus, it will be plus 2x minus 63. And here x square plus 2x, okay, uh, minus 99 we are getting. I hope this is clear for you. Okay. And after that, if you take the cross multiplication here, then those terms convert into the cubic. So that is 2x plus 2 into x square plus 2x minus 99. That equal to 2x plus 2 into x square plus 2x minus 99. So in this case, if you observe, if you want to try to solve this problem, if you want to satisfy this problem, your satisfying is nothing but how to get here same answer in the right side and the left side. That means it is satisfied of any value here. For that, there is a no need to take here. One is 63, am I right? One is not, one is 60. One is 60. Okay. The main thing, see, you can see here, if you take this value as 2x plus 2, if you put the any value here so that it is satisfied and it gives the zero value. Okay. So that means you can do here x value is equal to minus 1 you can put. So if you put minus 1 here, then the both side it is satisfied. We are getting the same result. Okay. Even though, let me try to solve here. Total quadratic into linear. Product will be here 2x cube. Okay. And it is important for us to solve this. But because we have to understand that. Okay. The next one here it will be 4x and 2x, that is 6x square. The next one here it will be 99. Okay, so 99 into 99, that is 198. So that is the x value. The another x value is minus, it is negative, then plus. So we are getting here 194x. And after that, minus 198 we are getting. Okay. And if you see the right hand side part, and if you observe very carefully here, 2x cube we are getting. After that, we are getting here 4 plus 2, that is 6x square. And the next one here it will be 63, that is minus 126 plus 4, that is minus 122x minus 126. So this is the values we are getting. Okay, I hope this is clear. So I used here vertical and crosswise sutra finding. So you can see this value cancelled out, this value and this is value also cancelled. Here very clearly you can see. Okay. Is it clear my point? Any doubt up to till?
Yes.
Okay, right. And if you see here, if you take, I mean, if you transpose the value one side to other side, then let us see what happened here. So 194x minus 122x, and after that let me take this value to this side. Okay.
98
So minus 198 plus 126, and here we are getting 72x, and here we are getting only 72, that is negative 7. The x value here will be 72 upon 7, cancel out, then x is equal to, we are getting 1. Okay. So this is a general question, yeah? And it is a simple equation actually, because your higher power terms are cancelled out. Okay. But that same one value we already obtained. Why? Because you can observe this is the total left side part and this is totally right side part. Okay. When we are getting like that, the multiplicand value, if you see in the both side, we are getting 2x plus 2 here, and here also 2x plus 2. Am I right? So in this way, when we are getting, if you satisfy this expression with any value, then both side will we are getting same thing. That means you have to make that value 0, then only it is satisfied. So that is the reason Swamiji was not bothering about multipliers. Whatever denominator we have, he is not bothering about that. He is just focusing on the numerator part are going to same or not. In case not numerical, numerator part. In case numerator part are same, then after cross multiplication also, we are getting the same answer. Are getting my point? Well, because we are doing the cross multiplication. If I equal these two numerators, that means in case by the in the solving steps, you are seeing that the numerators are same. That means if you make the numerator value equal to the 0, then whatever value you are getting, that is called 0 of the polynomial we call. Okay, 0 of the polynomial. That means that is satisfying that equation. If you satisfy that equation, the left side, both side also both are going to same. So that is the logic Swamiji was considered. So what you understood now? When we are numerator will be same, okay, when your numerator will be same, and the denominator value going to the numerator after taking the LCM, here also these two are going to the numerator, and after that, in case these two numerators are same, that numerator, that was samucchaya, that samucchaya will be same, then you can equal to the 0. So that is the reason Swamiji, whenever the numerator denominator's value is going to the numerator, and according to the plus symbol I am talking, they are going to add. And Swamiji was considering only numerator part only. So that is the reason Swamiji gives that when have these kind of problems we have, take D1 plus D2 and D3 plus D4 are same. Okay, are same. Then you can take directly that value and equate to the 0. Then you will get the final answer. That is 2x plus 2 is equal to 0 we are making. Then x is equal to minus. You got it, Swamiji logic? How is thinking? Yes? Yes or no? Please tell.
Yes.
This is the important. Actually, in the previous class, I couldn't discuss all these things. But later I realized that why not try exactly Swamiji point of view in front of you. Okay? So that is the main intention of mine. So that is the reason once again I'm taking these problems. See, first we have to understood why we are taking D1 plus D2, D3 plus D4. That is important. If you go blindly, there is a no use. You cannot find anything new concepts in mathematics. Okay, you got it. Why we are taking D1, D2, D1 plus D2 and D3 plus D4. Yes, are you getting my point? Please, clear or not? See, if you make this value 0, then it is multiplied by this one. And if this value 0, if you multiply it with this one, then you are getting both sides 0, means this question is satisfying particular point, particular value of x. Am I right? So the whatever blue color I marked here, like you have to make that 0, that is nothing but numerator part. That numerator part comes when you are taking the LCM, and that too the numerator will be same. Then there is a no change of the denominator values in the numerator after taking LCM also. Clear my point now? Yes,
Yes.
this is important. And yesterday, I mean, one more problem I saw select yesterday I taken. Okay, so see, this is the reason why we are taking D1, D2, and D3 plus D4. And Swamiji says that must to be equal. See, if you are making this value 0, okay, by putting -1, in case this numerator value if you are getting different, this numerator value if you are getting this different, then you cannot use this sutra, but because we are getting a different value. Am I right? Right. Let me take one more problem. Second example. By x minus 8 minus 1 by x minus 5, that equal to 1 by x minus 12 minus x minus 9. Okay, right. Let me solve it in a normal way. So I'm writing the direct step. Why? Because I know you can easily solve this problem step by step. So let me try to take the problem. I mean, next LCM part directly. I'm taking LCM here. X square minus 13x plus 40. And here what we are getting? X
X
square
squared.
minus 21x plus 108. Okay, plus 108. And so see here x minus 8 and x minus 5 are different actually. If you see, when we have the in the LCM chapter we are discussed, when we have co-prime numbers in the denominator, co-prime numbers, right? Because the co-prime means their factor should be one only, common factor. In this case, you can take directly the product of the denominator as a LCM. Am I right? The same concept I'm using. The same concept.
X
And,
plus 5 minus x minus 8.
yeah. So then this is going to numerator x minus 5 minus
Minus x plus 8.
plus 8. X minus 9 minus x minus 12. Okay. So in this case, these two are cancelled out. And here
Plus 12.
sorry.
Plus 12.
Oh, this is plus 12. Plus 12. So here we are getting 3. See, 3 upon x square minus 13x plus 40. That equal to again 3 upon x square minus 21x plus 108 we are getting. Now you observe very carefully. Now you can observe very carefully. Here what happened? Here what happened? You have to observe. So in this case, if you see numerators are same, there is a no problem. You can cancel out all. Because it's the numerator, so I'm not going to consider this one. Let me take the cross multiplication. Then what we are getting x square minus 21x plus 108 is equal to x square minus 13x plus 40 we are getting. So that you can see this is x square, this is x square cancelled out. Then 21x minus 13x is equal to 108 minus 40. Okay, so how much we are getting here? 8x is equal to, here we are getting 68. I hope, yeah, 68. So that equal to x is equal to 68 means 17 jars, 2 jars. So your x value here it will be 17 by 12. Okay. Now what? Let me one thing here. Here the numerators part, if you observe, they are constant value. There, what is the constant value? That means by this problem, we can understood here what we can understood. Here, when you are taking the problem as it is, we are getting the x value. There is no doubt about it. But the numerator part, if you see, they are same, but they are constant. In the previous case, you see, we are getting some linear expression here. In case this type of numerator we are getting, we can directly equate to the zero. But in this case, we are not getting. So in case that means in this case we are not getting means you cannot take d1 plus d2 and d3 plus d4. Why? Because if you are taking d1 plus d2, d3 plus d4 in the numerator, you are getting a numerator, you are getting the number, just constant value you are getting. Am I right? Yes or no? You see, d1 and d2 you are added. One is the negative, that is automatically multiplied with positive value. Then every number becomes negative. That is a different point of perspective. But what I am saying here, if you are taking d1 plus d2 concept on this problem, the numerator part going to vanish. We are getting only one extent. So we cannot do anything. So what we have to do here, you have to change that problem that like previous one. In the case of if you are adding d1 plus d2, d3 plus d4, if you are adding, then the numerator part may be a linear number or expression so that we can get the answer directly without solving. That is the point I'm going to discuss here. Okay. Now see, let me check here whether I can update d1 plus d2, d3 plus d4 or not. By normal process only, let me discuss. So here what we are getting, x square minus 17x plus here what we are getting, x square minus 17x
60.
yeah 60, and the numerator what if you add, that is 2x minus 17, here 2x minus 17. Okay, by the cross multiplication, 2x minus 17 into x square minus 17x plus 6, that equal to 27 minus 17. Okay, so x square minus 17x plus 72 we are getting. Suppose if you make this value 0, then both sides will be satisfied. So that the common term, whatever will be there, we can take that value as a 0. Then x is equal to 17 upon the same value we are getting. So that is the important. In case there is the d1 plus d2, d3 plus d4 are same or not, we have to check. Along with that, in the numerator part, that is d1 plus d2, we are getting a linear expression or not. That is the important. Is it clear? Yeah. And yesterday also we have tried one more, different one actually. Just we have tried, but we got the answer yesterday. Let me try to solve that one. Suppose d2 minus d1 if I am taking, when we have see, if you are taking these two values, x will be cancelled out. Am I right? Okay. X will be cancelled out. Along with that, they in the right side, left side, they are not equal. Let me show you that. Suppose the direct question from this question only I'm talking. d1 plus d2 if you are taking, that is 2x minus 30, and d3 plus d4 if you are taking, then you are getting here 2x minus 21 you are getting. Is it clear my point? That means they are not same here. That means you cannot take sunyam. You cannot take sunyam because they are not samya. In that case, let me try to take this kind of relation. Let me check whether it works or not. I don't know. Why? Because Swamiji is not given there. Okay, that is d2. So x minus 5 plus, not plus, it is minus x minus 8. That equal to 3. Here also we are getting visible. So this is also not working. Okay, this is also not working. That means immediately the given problem you have to convert into like this. And after that again you have to take here d1 plus d2 and d3 plus d4 are same or not. So in the both case, we are getting 2x minus 17 and 2x minus 17. So the rearrangement the fraction. What is the concept we are using? Rearrangement in the fraction part. I mean, yeah, fractions. Okay. So now it is same. So directly you can take this value. So I'm very clearly explaining you. We are focusing on the numerator part in the right side and the left side. They should be same. Then we can find the answer. And remember one thing. Remember one thing. It is a simple equation. Why? Because after multiplication also, the first two terms of the quadratic are same. That means it having only single value. It having only single value. That means this problem is linear problem here. That means simple problem. Clear? Any doubt, please you can ask. Why? Because the next problem I'm going to very different problem. Yes, clear or not? What about you, Parshuram sir, Padmajaji?
At what stage we have to decide which method we have to adopt?
Sorry, I couldn't understood, sir.
At what stage we have to decide? I have to do like this.
No, no, no. This is not we are going to decide. See, let me talk about here. So first, the whatever explanation I give to you, that is why we are taking D1 plus D2 and D3 plus D4. Why we are finding this whenever that kind of problem is given. Okay, suppose the question is given like this. Okay, so this is the problem is similar to so far what we are discussed. Am I right? So whenever this kind of problem is given, then we have to check whether numerators are same or not. Okay.
That is first stage.
We have to check numerator are same. Whenever numerators are same, then
Second
when you are
stage.
doing the cross multiplication there, okay, then we are getting the same thing. That is the point.
X minus 3 and then 2x minus 6.
2x
Yeah,
minus
so
6 here also. No.
2x
Let me take this
minus
is
2.
place. No, place. Otherwise, it is
Yeah.
not going.
Yeah, 2x plus 2.
2x plus 2 here also getting. If you add these two terms, so
2x
2x
plus 2.
plus 2. So we can take this
Then
value
we can
0.
stop here. Yeah,
Yeah,
we can
then
stop
this
here.
is equal to, you can direct write minus 1. Why? Because this is the d1 plus d2 is nothing but this one. This part.
Right. If it is
We
not
are
there, then
finding
again,
we are finding that one. Why? After solving all that problem, total problem, we are observed that Swamiji was focusing on the numerator parts only, not the denominator parts. He's not.
Okay.
Why? Because after whenever numerators going to be same, after class multiplication, if you satisfy the numerator part only, the left side, right side product will be going to satisfy.
Yeah.
If you
So
put this,
in this case, when left side is not satisfied and we found the constant, we are trying that Vilokanam, that minus we bring here, it may work.
Maybe. I say no.
Maybe
No.
only.
Maybe. No, it not works. Why? Because D2 minus D1 is nothing but this is the part only I done there.
Yeah, constant.
This is the part. There is anything. So whenever it is not satisfying, that means when you are subtracting, the subtraction symbol is given. So D1 plus D2, D3 plus D4 are not going to satisfy there. Then try to
because minus 0 will come.
Rearrange that. So rearrange the fraction whether we are getting D1 plus D2 plus D3 plus D4 going to same or not. We have to rearrange it. In case there any not we are getting anything, then you have to go with normal.
Okay.
This is the one of the way to understand why, because स्वामी जी का सोच क्या है पूरा प्रॉब्लम देखने का नहीं, सिर्फ ये देखने पर बस हो जाए. Okay, right.
Yeah.
Let me take here one more problem. Yesterday, I mean general form also yesterday I discussed. This is the general form actually. A or B 1 by x plus. And see here, this is the numerator we have to take as it is. And extra, you have to add any number to denominator of the first fraction in the left side. Plus 1 by, take the second denominator and whatever extra value added here, you have to subtract from here. So this is the logic Swamiji used. Clear my point? Okay, this is the logic. So if you see here, d1 plus d2 and d3 plus d4 if you are taking, so that is x plus b plus x plus c, that equal to 2x plus b plus c. And here x plus b plus d plus x plus c minus d cancel out. 2x plus b plus c. So 2x plus b plus c you can put equal it to the 0. Then your x value is equal to minus half into b plus c. So whenever questions are given, like in the previous one question I taken, what is the question? 1x minus 2 plus 1x plus 4, that equal to 1x plus 3 and plus 1 minus x. This is the question I selected. You have to verify. You have to verify whether d1 plus d2 and d3 plus d4 is going to work or not. Then simply see the first, this is the fraction we are taking here and we are adding something extra to that. That means x minus 2 we have. If you add something to that, then you are getting x plus 2. Then how much we have to add here? That is plus 5. Am I right? Right. So the next one, if you take this part, that is x plus 4, that equal to x minus 5, x minus 1. I already told you, whatever d value you added, in the next denominator, it's going to subtract. So let me subtract minus 5 here. Then it's going to satisfying yes or no? Yes? No, it is going to
Both will
satisfy.
be equal. Yeah.
So you can directly know, you can apply here d1 plus d2 and d3 plus d4 you can apply. Otherwise you can do very simple way. You can put the values in this formula also, you will get the answer. In the previous case, how much we got the answer? Minus 1. Am I right? Minus 1 we got. Okay, minus 1. See, x is equal to minus 1 by 2. Here b value is minus 2 and here c value is plus 4. Okay, then x is equal to minus 1 by 2 plus 2 cancelled out, then you are getting direct minus 1 value. You can see. So you can use either formula or d1 plus d2 is equal to d3 plus d4 also. You can use it. There is a no problem. Clear?
Yes.
Not today I am satisfied.
Okay, correct. Satisfied.
Yeah, no, I am satisfied. on this on this topic, I am satisfied.
Okay.
Why? Because I felt that yeah, you're slowly getting the concept why we are
Yes,
taking
yes.
D1 plus D2. Otherwise, yesterday, similar if I am taking yesterday's class type, maybe you have some doubt why we are taking D1 plus D2, D3 plus D4. You also applying that formula mechanically without any reason. But today I give the clarity on it. That's the reason I am happy. Right. Let me take here one more problem. 1x minus 7 minus 1 by 3m minus x is equal to 1 by 2m minus 1 by 9. Okay. If you let me solve this first, not m or x. Okay. Let me solve in a normal way. Then let me think about the next procedure. Okay. First, what we are getting here, that is
The same
3x.
method or different method to this?
Same. One
Okay.
more last problem. One more
Okay.
last. This is here we have the pluses actually.
Yeah.
And in this case, we have minus, then we are done rearranging the terms.
Yes.
Let me check whether directly we will get the here without rearranging or not. We can easily understand by observing the numerator part. Okay.
2x. It will come 2x. So it will need not rearrange.
Let me think that. I don't know. Let me think that. Okay. What we are getting, what we have to do here. Yeah, 3x. Okay, this is 3x. Next,
Minus x plus 3.
minus
So
x square minus 21 minus into minus 7x. Okay, here 18x minus 9. Clear my point?
Yes.
Then here 3x minus x
Plus
plus
3.
so 9 minus 2x plus 1. So that minus 2x plus 10 upon. So minus x square plus 10x minus 21 here. And in this case, minus 2x plus 10. And in the denominator, 18x minus 9 we are getting. So by the cross multiplication, you can see in the both side, we are getting the same, you can observe here. We are getting the same thing. And the 2x plus 10 into minus x square plus 10x minus 21. Yeah, clear?
Yeah.
That means if you make this value 0, then both side will be satisfied. So that what we can do here, minus 2x plus 10 is equal to 0, then x is equal to minus 5, you can take. No problem. Up to here, no problem. We got the one answer. But if you try to solve this problem, plus 5, right? Because 10 also going to the right side, that is going to negative. But if you try to solve this problem, let me check whether I'm getting directly or not. Why? Because the previous problem, if you are taking without rearranging the problem, if you are solving, you're getting the numerical part there. But this question little bit changed. Pattern is changed. Instead, like if you see second fraction in the left hand side, that is 3 minus x. In the previous case, x something will be there. That's the reason we are getting numerical. And, one more thing, if you see here, we got don't x in the denominator. We have only constant value. So that is the reason I interested to solve this question generally. Let me check why we are getting directly with the d2 minus d1 and d4 minus d3. That is the thing we are done here. The numerical part is nothing but that was why, because we are using negative now. So d2 goes this side and d1 goes to this side. Am I right? Are you getting my point? So this is the formula we are using. Even though we are getting the answer, we have to find out that why we are getting that. So if you multiply, let me write here, that is minus 20 now, 2x plus 10, okay, 18x minus 9, that equal to minus 2x plus 10, and minus x square plus 10x minus 20. Okay, if you see now what happened here. First, if you multiply minus 36 x square, we are getting. Okay, and the next one here it will be plus 18x plus 180x. So that is plus 198x minus 90. Got it correct? Yeah, that's great. So now it is 2x cubed completed. Now it is minus 20 minus 10. That is minus 30 x square. Next, minus 42. That is plus 2 and plus 100. So that is plus 142x minus 210. Okay. See, the finally we can see that this is a quadratic equation. It is not a simple equation. Am I right? So it having three values. How many values? Three values it having. Three roots also we can say that. In the previous case, whatever problem we are selected there, okay, those problems are simple equation, but because highest degree term is cancelled out there. That is the reason the last part will be a simple equation. But in this case, this will be our cubic equation. It means having three value. So because of the three value and because of the difference between the original pattern and this question, some changes are there. X minus 7 and the 3 minus x we have. And then the last two fraction only in the numerical. So some changes we have. That is the reason we are getting here cubic equation. Let me check can we find remaining two roots of the given question or not? Okay, by d2 minus d1 we got the answer. There is no problem about that. But if you rearrange the terms, let us see, maybe we get any some remaining factors or not. Let me check that. So that is 2x minus 1 plus minus 3 minus x. I already told you how we check that one. Here, see how much the difference will be there here. So x plus 6 is there added. So here also we have to subtract here. We have to subtract the same value here. So 9 minus x minus 6. So exactly satisfied. It means we can take here d2 plus. So
X
d2
equal to
plus.
minus 6.
Yeah. So d2 plus d3, d2 plus d1, right? And d3 plus d4. That how much we are getting? These two values are x
Minus 6. X plus 6.
minus 2 plus 2. Both are here also plus 2 we are. It is equal to 0. Then x is equal to minus 2. That means now we got by these two ways, and this is the one way. Matlab d2 minus d1 also we can consider in case any like numerators are going to same. In that case only we have to take like that. We are taking d1 plus d2, even though we are getting some value, maybe we are getting here two values, but one more value we have to obtain by the division method only, I think so. Okay, by division method only. Why? Because one factor here, one x value is 5, and another value will be here 2 we have. You can observe here. Yeah, is it clear? Okay. Here you can do one thing. We don't know the exactly what is the quadratic equation is. I mean cubic equation here. If you know the first term and second term, you can by using Adhyam Adhyana Antyam Antyana Sutra, we will deal with that sutra in quadratic equation. Okay. If you want to find for one more value, that is another root, but that you have to solve this total cubic equation, how to convert it. After that, by using these two roots, we can find another root here. So that is a point. So I'm not going to find it out. So this is the thing. Okay, this question having three values, three answers. Why? Because it is a three answer. Why? It is a cubic equation, not compared with previous problem. Clear? And see, very wonderful point here. Let me tell you that. And here you can see what happened here. Let me take, yeah. If you see here, if you see, here we have 1, and here also we have 1. That is 1 by 1. And here also we have 1, and the x coefficient is 1. We have the plus symbol. And here also we have 1, and here also we have 1. The numerator part and coefficient of x. That means this is the value satisfied. Both side we are getting the same value. That means in case any question are in this form, in case these are satisfying, then we can try there d1 plus d2 plus d3 plus d4. This is also one of the observation. That means why I'm taking this concept here. Suppose sometime we have in the numerator we have different values. Am I right? Then how to apply d1 plus d2, d3 plus d4? Then we are going with this condition, and we are trying to apply on the different type of problems. The both side answer will be same. Then you can apply this. Let me tell you one problem here. Okay, let me tell you one problem like that. Suppose 2 upon 2x plus 3 plus 3 upon 3x plus 2, that equal to 1 upon x plus 1 plus 6 upon 6x plus 1. Now in this case numerators are not same, but just now I show you here, this is the condition we are taken from here. That means the left side right side should be equal. Let me try here whether it is going to same or not. So 2 upon 2 plus 3 upon 3 is equal to 1 upon 1 plus 6 upon 6. Okay. So you can take the LCM here. Or if you take the LCM, 6 plus 6, that is 12 upon 6. Here we are getting 6 plus 6, 12 upon 6. So both are same. Am I right? Both are same. That means we can apply here actually. We can apply here. What is that? D1 plus D2 and D3 plus D4. But it will be applicable when we have numerators are same. See in the general question, generalized question, the numerators are same. So here also we have to make the numerators same. Then only we have to apply this one. That is the Vilokana observation. If you are solving many problems, then you can realize that. So this is a condition we have to apply. Otherwise, we cannot solve. Okay, by the practicing more problem only we can observe these kind of points here. Okay, so how we can equate? So if you see, the main point is we have to make our numerator should be same. So whatever numerators we have, you see 2, 3, 1, 6. So what is the LCM of all these numbers? Huh? What is the LCM? LCM is 6. Suppose if you are taking, if you are making, not taking, if you are making, numerators are going to same. That is a 1 point. Or you have to make the coefficients of the constants. That is also same thing here, but because both are same number actually. So be careful according to the problem. We have to focus on here 2 points. The 1 point is here, 1 point is here. The numerator should be same. That is the 1 point we have to consider. Why we are making numerator same means here, after doing cross multiplication, we have to get the same result both sides so that we can apply this condition. But if you have the different numbers, so the you can see here. Let me show you that. For example, you can see. So all the x's coefficient, numerical coefficients are identical here. So if I'm cancelling this value here and this value here, because both are same, after cancelling, you are left with this part and this part only. From that, you can cancel this value and this value also. This happening because of after doing the cross multiplication LCM, you are taking up for the question, the highest degree terms coefficient should be equal. For that, we have to make them equal. That is the important point. So that is the reason let me equal here. So 6 I want to take. So here I am multiplying by 3. Here also I am multiplying by 3. Here I am multiplying by 2. Oh, sorry. Let me change the color so that we can easily identify here.
Do it in the next step so that if you can.
Yeah, that is also okay, fine. So that is 3 into 2 upon 3 into x plus 3 plus 2 into 3 upon 2 into 3x plus 2, that equal to 6 into 1 upon 6x 6 into x plus 1. So 1 into 6 upon 1 into 6x plus 1. Okay. Now 6 upon 6x plus 18 and 6 upon 6x plus 4 is equal to 6 upon 6x plus 6 plus 6 upon 6x plus 1. Now see, it is look like this condition. Am I right? Yes. And here we can satisfy this condition also. Are getting my point in this problem? Am I right? In this problem. So that now we can directly apply here D1 plus D2 and D3 plus D4. Yes, are getting my point? So in the both cases, how much we are getting? 6 plus 18 plus 6x plus 14 and 6x plus 6 plus 6x plus
1.
I am writing mistake even though you are not identifying that. Why? You are
6,
not
6,
listening.
9.
Why? That means you
4.
are not listening. In case it is, I mean, both
13.
parts are not going to same, then we cannot apply here. Okay.
6.
So 12x plus 13, and here also 12x plus 13. Okay. So we can take our x value is equal to minus 13 by 12.
12x plus
Sorry?
7. No?
Where 7?
Second one.
Maybe I take question wrong. I take question wrong. So here 7 you have to take. Then only it is satisfied then. Otherwise, this problem comes under here. No, it is okay. Okay. You
Yeah.
have to take 7. Why?
Then
Because
13. Now it is correct.
now it is 13. Now it is 13. Why? Because why I am writing blindly here because of almost the same problem we are selected here. So I felt that maybe the sum going to same. That's the reason I write directly. But just to observe that I written 1 there. Actually, it is not 1. It is 7 actually. Okay. I hope you are getting very clearly concept why we are applying, how to apply everything. Am I right?
Yes.
Yeah. So yeah, I am giving to one problem. So try to solve it in the tomorrow class, or you can put in the WhatsApp group also. The question is 1 by x plus 3 plus 3 upon 3x minus 1 is equal to 1 upon x plus 5 plus 3 upon 3x minus 7. Okay. So you can find out this one. Okay. And do you know one more thing? Do you know one more thing? Swamiji gave one alternate formula for this. Actually, we are done. We are taking the LCM here. Am I right? We are taking the LCM. After that, we are equaling the numerators, everything. But Swamiji given one alternate formula here. So that is alternate. Let me talk about alternate. So alternate formula here. So instead of observing all these things, Swamiji give alternate. What is the alternate? The alternate formula is here. Uh, N1 is multiplied by D2. Yes. And D, no, N2 is multiplied by D1. That equal to N3. That is N3 means this one is multiplied by D4. And N4 is multiplied by D3. Okay. If you are equalizing the numerator is nothing but you are doing this. This is only there. Why? Because taking the LCM and if you are doing cross multiplication, this is one is multiplied by this one. Am I right? Yes or no?
Yes.
Already I told you we are solving the problem based on this numerator part only. Yes.
Yes. Yes.
Then if you are directly you have the chance to take the LCM and then you have to you see. My exactly point is if you are taking LCM here, you are finding some numerator value. If you are taking LCM here, if we can find the numerator value, in the previous cases, we have 1 and 1 here. 1 and 1 means if you are multiplying this into this, you are getting the again D. Let me write here so that you can understand. This is the value 1, this is the value 1, then you are getting this part only. Am I right? So that is the
Yeah.
reason we are taking here. You take this is one, this is one. So D4 and D3 we are checking in the previous cases. So we can numerators are 1. But in this case, numerator is not 1. Then directly the normal way you can do it, normal way. That means direct cross multiplication you take, and in case they are same, then you can find the answer directly. Then why we are going with this concept? This is a concept is important for upcoming problems, not for this problem. So far, whatever we learned, That is nothing but this is a general formula for all the problems. So far we have discussed type 6 problems. So then what we are getting here, if you do the cross multiplication everything, okay, you will get the answer also. Now we have the two tasks. One task is solve it normally by taking LCM, and the second one is try to apply this formula. In the both cases, you are getting the same answer. That means you listen class very carefully.